Good morning. We are starting chapter 3, part 1. I'm glad we're in this chapter now while we're at home because it is all review. So some of you on Friday got started. You didn't even take notes. The first few pages are notes. And then in was your homework. So your homework for tonight is this worksheet. Now, do you have to do the notes? No, because this is review. You graph two equations. Wherever they intersect is your answer. Substitution, you have to get a variable by itself. Substitute into the other equation, you get your answer. Elimination, you have to line them up in standard form and eliminate one variable. So some of you were going away. I remember this. Some of you are like, I haven't seen math since fall last year. That's fine. I don't expect everyone to be like that. So you can take the notes, but you don't have to. Notes are there to help you better understand the homework and curricular aim that you are learning. So your aim for today is to be able to solve a system of equations and figure out where they intersect. So equations represent situations. So we want to know when two situations are going to be the same, and that's where they intersect. We can't use words and just kind of talk about it logically. We can put words and translate them into equations and mathematically or algebraically figure out when that will occur. So it might not make sense right this second, but I'm going to show you the methods. And then when we're doing word problems tomorrow, that'll make sense of how you're able to see when two situations are the same and when exactly that is. So I'm teaching you the tools today so that you can figure out the actual problems tomorrow and it'll make more sense. So I know some of you are like, oh, I know that I want to see where they intersect and I get my answer, but I don't know why I'm doing this. Well, we'll discuss more of that tomorrow once you have a better grasp on the tools today. So we're going to go back to Algebra 1. We did some of this in geometry or with your geometry teacher. And we're going to solve a system by three methods. We're going to graph, we're going to use substitution, elimination. So if I were to graph these two linear equations, they're either going to intersect and create a solution. They're either going to eventually algebraically simplify so that they end up looking to be the same equation so that they have many solutions, or we're going to graph them and they're never going to intersect. So their situation will never be the same. Okay, so it says when solving a system of equations, you are looking for common solutions. If a system has at least one solution, it is called consistent. Think of like consistent people. They have solutions. If a system has exactly one solution, it is called independent. So consistent independent or consistent dependent is when you have many solutions. If a system does not have a solution, it is called not consistent, but inconsistent. It's just good to know terminology. So if the textbook or a professor is referring to the inconsistent system, you're like, wait, what are they talking about? It's math terminology. So that is an inconsistent system. They'll never share the same answer. This is a consistent dependent system because you have an answer, but you don't have just one. You have many times they'll be the same. Okay. And then here, this is when they will intersect at one point. They'll be consistent independent. And you know what? I'm going to give you a really good example today of all of these types of situations with one word problem at the end, but I won't give you word problem homework till tomorrow. So it says one way to solve the system is by graphing, then find the solution. So here and here, you need to rearrange both into slope-intercept form. Then when you do that, you're going to graph the equation. Well, I'm just going to do one on your homework rather than make you do it again and do it again and do it again. Because most of you already started completing your homework Friday in class. So if we go to here like this, number 4, you need to get y by itself. So you need to move 4x to the other side. When you do move it to the other side, it is now negative. Here, we're going to move x to the other side. So be careful. Y is still negative. X is negative, and your b is positive. But when you multiply by negative, all the signs change. And be very diligent. Because look, I even just messed up. So you begin with B and you move with M. You begin with positive 2 and you go down 4, 1, 2, 3, 4 over 1. Oh, we got to go right one because it's got to be negative. Okay, 1, 2, oh, let me go 1, 2, 3. Oh, let's do that. And then, let's see. Do we go down 1, 2, 3, 4 over 1? Yep. And then this one, we begin at 3. And we go up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1. So we're here, and we are here. I don't like this. Where are they intersecting at? They're intersecting at a weird point. Let's see. You brought 2 to the other side, or 4 to the other side. Begin at 2, down 1, 2, 3, 4 over 1. Here, oh, you know what I did? I looked at the positive 3. You're at negative 3. Shame on me for using a pen. Okay, and then you go up 1 over 1. So why did my gut, did I know that was wrong? Because their intersection wasn't pretty. So I said, okay, maybe it's incorrect. It doesn't have to be, but then the point of graphing wouldn't be useful. So you have to begin at negative 3, up 1 over 1. Oh, this is a nice point. Your solution is 1, negative 2. So this is a consistent, independent solution. They didn't ask you to classify. I'm just writing it down. It'd be beneficial to help you while you're doing your homework. Okay, let's try another one from your homework. Let's get 8x to the other side. If I put y on this side, it's positive. And then I keep that negative 8x and I keep that negative 4. Oh, they end up being the same solution. So I can't really go down 8, but I can go up 8, left 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh, the same. So I see some kids wrote on their papers on Friday, all solutions, infinite solutions, many solutions, any solution. Which one is it? They don't have any solution. 3, 1 is a solution and it doesn't work. All real numbers I saw. No, you can't pick any number. It's just many solutions. So you could write infinite solutions, many solutions. Okay, consistent, dependent. So if it says find the solution, there's infinite solutions, classify the system, consistent, dependent. Okay, and start chipping away at that chapter review while you're doing these. All right, make sure you finish this page. And then now we're gonna go to, on your homework, solve the system by substitution. So let's go back on your notes. I just didn't think we needed to do a ton of graphing. You've done it over and over in chapter 1. This is like Keystone Review. We're not gonna look at that here. It says another way to find a common solution is to use substitution. In this method, one of the variables is replaced with an equivalent expression. Solve the system using substitution. Well, if I can somehow get one of my equations to have only x's or only y values in it, I can solve. I can't when there's 2 different variables. So the method here, as long as you have one variable by itself, whenever you see that variable, substitute the other one in. So every time I see a y, it is equivalent to 3x minus 7. When I do that, I'm able to get the same variable and I can simplify and then solve. 6x minus 6x is 0. You can write 0, but you don't have to. And you get 14 equals 12. Is that true? No, it's not true. Therefore, no solution. Then classify, inconsistent. So if I have an untrue statement, that means there's not going to be a variable that ever works to make these 2 things the same. They're inconsistent. If I were to graph those, they'd look like this. They're never going to share an answer. Okay. Here, I don't have an x or a y by itself, so I have to get one by itself. Getting this x alone means I'd have to divide everything by 5. Getting this y alone means I'd have to divide everything by 2. Getting this y alone means I'd have to divide everything by 3. And getting this x alone is just a simple addition. So let's do that. Let's make x alone. Then everything's going to turn positive. So every time I see an x, it's equivalent to 3y plus 9. It doesn't have to just be y equals. It can be x equals. So it's no longer 2y plus 5x anymore. It's 2y plus 5 times the quantity 3y plus 9 equals 11. 2y plus 15y plus 45 equals 11. 17y plus 45 equals 11. Notice I simplify before I solve. A lot of students kind of like stop here and start subtracting now. Just leave it like that. Subtract 45 from both sides. 17y equals negative 34. Y equals negative 2. Well, I'm not done. I need to find an x and y coordinate. So that means I need to substitute y back into either equation. Now, it doesn't matter because the whole point is that they share that equation. I'm just going to pick the first one. So 3 times a negative 2 minus x equals negative 9. You're going to get negative 6 minus x equals negative 9. Negative x equals negative 3. X equals 3. So your solution is 3, negative 2. It says solve the following and then classify. 3, negative 2, it is consistent, independent. Okay, so then go back. What I would do is I would complete a section like this in your notes. I'd pause it, and then I'd go back and work on substitution for a while. Then come back to the video, and let's do elimination. The rest of this is word problems. We're going to do these tomorrow, okay? So it says, when both equations are written in the same form, the elimination method is a good choice for solving the system. In this method, you multiply one or both the equations, so the coefficients of one of the variables are opposite, and then you add the equations. This eliminates one variable. Solve the system using elimination, and then classify. So are these equations written in the same form? Yes, standard form. It doesn't have to be standard form just as long as they're lined up. In this method, you multiply both or one of the equations so that the coefficients of one variable are the opposite of the other. So if I have a 3, I want a negative 3. If I have a 2, I want a negative 2. Well, here, I'd have to make these both a 6, so I'd have to change both of them. I don't like that, but I have a negative 2 here, so if I put a positive 2 here, a 2 and a 2 will cancel. So let's do this. Let's just change the first equation. So 4x plus 2y equals 16. And it says, solve, in this method, you multiply one or both of the equations, and then you add the equations. So you have to add, you get 7x plus 0. Do you have to write 0? No. Equals 21. So 7x equals 21. X equals 3. But I'm not finished because I need to know what the y value is. If I put 3 back in, that's 6. 6 plus y equals 8. That must mean y equals 2. You can leave it like this or like this. Consistent, independent. Did it ask to classify? Yes. Okay, so make sure you go back and do did I do this? Did I do this? Did I do this? Okay. Here, this equation's fine. I'm going to rearrange this one, so 3x is over here. Now it's in standard form. So I have a 6 and a negative 3. I have a 5 and a 10. So I have to multiply either one of these to get to here. I'm going to multiply by 2. When I multiply by 2, I'm going to get a negative 6x, negative 10y equals 20. When I add them, I'm going to get 0x, or just 0, plus y, well, 0y, which is just 0, and equals 25. I have 0 equals 25. I don't care if it's 0 equals 0, 1 equals 7, whatever you get. Is it true or not true? That's not true. No solution, therefore inconsistent. If I got 25 equal 25, then that would mean it's the same line, and that would mean it would be consistent dependent. Okay, so now you're going to go back to your homework and solve by elimination. Okay, the answers are up under Chapter 3, Part 1, under homework answers. As you have questions about these, circle them, mark them, and then send an email probably Wednesday or Thursday and say, can we go over these ones? And I'm going to make a video going over all the homework that you had that you have questions on. So if people have like 4 questions from each day, then I'll make a video on 20 questions. Okay. So you're not handing this homework in. These are problems that are just going to be on the homework quiz. And you can use your homework for that. All right, I'll post the next video soon.